Hey guys, so I'm going to be filming the questions 1 and 2 on chromatic dispersion in the homework optics for spectroscopy. So the question states that a given spectrometer uses a flint glass equilateral prism. White light is directed onto the prism at an angle of 46 degrees to the normal line. The light is dispersed into the visible spectrum. At what angle to the normal does red light leave the prism? Index of refraction for red light is 1.662. So for this I start off with Snell's law, and I rearranged that to solve for the refracted angle since that's what we're going to start off with. And this is what I kind of drew out the picture to be. So this is going to be the refracted angle right there. They give us the angle of incidence right here, which is 46 degrees. I also told this is 90 degrees. So after I figured out, I rearranged the equation and I figured out the refracted angle, 25.65 degrees, and then I solved for alpha, which is right here, and I did 90 minus the refracted angle, which gave me 64.35 degrees. And then I also need the beta angle, which I labeled all these angles. You know this is 60 degrees because this is just the standard angle for the prism. And so the beta, since this is like a mini triangle, we know alpha and we know this is 60. Since there's 180 degrees in a triangle, we did 180 minus 60 minus the alpha, which gave me 55.65 degrees. And then to solve for the angle of incidence for the second one right here, I just did 90 minus beta, which gave me 34.35 degrees. And so after getting that, you go back to Snell's law and you just plug in the values. And here we go, we just plugged it in. We used N glass and the index of refraction for air. And you get the angle of refraction for red light, which is 69.68 degrees. And so on to the next problem, which involves the angle of refraction for the red light. So a second one states that what is the angular difference between the position of the previous problem for the red light and the angular position for green light? The index of refraction for green light is 1.674. So pretty much you just follow the same pattern as you did for the red light, and you would get the first angle of refraction to be 25.45 degrees, and then you did the same process to solve for alpha and beta, and then you got the angle of incidence for 35.55 degrees, and then you used Snell's law again to solve for the second refracted angle, and then that's the refracted angle for the green light. And the question specifically asks for the difference, so you just do the larger minus the smaller value, which gives you 2.01 degrees. Thank you.